I'm realizing that I don't have any videos this week that show you how to apply the torque equation. So I'm going to fix that problem right now. Let's imagine we have a little bolt here, right? And then we have a 1 meter wrench that we're using to turn this bolt. Okay, so we can turn it this way or this way. And let's suppose that there are some gremlins pushing on this wrench in order to have dominance over which way it's going to be able to turn. Okay, let's suppose that one of those gremlins, gremlin 1, is up here pushing at F1 equals 2 newtons. Okay, and then there's a second gremlin, and so remember this whole thing is 1 meter long. And there's a second gremlin pushing over here with 4 newtons at an angle of 30 degrees with the wrench itself. Okay? And then lastly, there is a third gremlin up here pushing with a force of 6 newtons. Okay? And it's applying that force at an angle with the normal this time, not with the wrench, but with the normal at 50 degrees. Okay, what is the net torque acting on this bolt? All right, that's the goal. What is the net torque? So just like with net forces, we want to add up all the torques, right? And there is a torque for F1, a torque for F2, a torque for F3. For every force acting on an object, there's one torque. So we do torque 1 plus torque 2 plus torque 3. But torque is a vector, so we have to be careful about the direction. So it turns out that any force that makes an object want to go rotate counterclockwise, that is a positive torque. And any force that makes an object want to rotate clockwise, that is a negative torque, okay? So in other words, F1 and F3, those both want to make this rotate clockwise. Those are going to be positive torques. F2 is going to want to make this wrench rotate. This is going to rotate clockwise. Those are counterclockwise. And so rotating clockwise, this will be a negative torque. So this one is actually negative. So I can take this away and put a negative sign there. Cool. All right, now we have our signs taken care of. So let's find out what these torques are, right? So remember, the formula for torque is F R sine theta, where theta is the angle between the force and the object that you're trying to turn. So in the case of F1, we have 2 times 1, right? R is 1. R is the distance from where the force is applied to the axis of rotation. That's full 1 meter. Times sine of, well, that's 90 degrees. So it's just sine of 90. Okay? Minus F2 has a force of 4. Oh, and I didn't mention, so this here, this is 60 centimeters, and this here is 10 centimeters. So R for F2 is going to be 0.6 meters, right? 60 centimeters is 0.6 meters, times sine of 30, right? And lastly, for T3, we have a force of 6 newtons times a radius of 10 centimeters or 0.1 meters, sine of, do we want to put 50? No, because this angle is with respect to the normal. We want the angle with respect to the object that we're trying to rotate, and that's 40 degrees, right? So this will be sine of 40. Okay, adding these together, I get that this is 2, I get that this is 1.2, and I get that this is 0.38. And adding all those together, I get 1.18. And the units for torque are, well, that's a newton, and that's a meter, so it's just newton meters. No fancy name for it. Net torque is 1.18 newton meters. And this gives you an idea of how to use the torque formula and apply it to a situation where you have multiple forces acting on a single object.